So let's jump into the Breeze software and look at the new user interface. And we will first be welcomed by the new home screen. And here we can see all of the already existing projects within this workspace, but we can also, here towards the left, create a new project, which creates an empty project. We can import images if you already have images on your computer that you want to analyze within the software. You can import projects. Let's say you have a colleague who works on their computer on a project and you're supposed to continue. They can export the project, you can import it on your own computer and continue where they left off. Or if you're new to the software or just want a refresher, you can always download tutorial data and follow along the tutorial guides. Any of these that you see here are available tutorial data. And another major part of this new home screen is that we have divided the recording and the analyzing of the software into two different parts. So we have the recorder, where you do all of your data acquisition, and you have the analyzer, where you look at the spectral data and create models. Basically anything that you accept the acquisition of your data. And I was thinking we will follow along from start to finish with the project. And since it's the Swedish National Day tomorrow and we usually eat strawberry cakes, I'm craving strawberries, so let's look at some strawberries. So we create a new project, call it Strawberries, and we will be relocated into the analyzer. But let's first press home here, so we come back to the home screen, and we can see now that we have a new empty project. So let's go to the recorder and do some recording of strawberries. When pressing the recorder from the home screen, we get to select which group we want to store our images in. And these groups are basically folders where the images will be stored within the project structure. So either we use the default group, which is created with every new project, or we create a new one. So we will create a new one and call it Day 1. Now we get into the recorder view. But before we can start recording, we need to connect to a camera. So we'll press settings in the lower left corner to get into a settings menu. And here for the camera, we can see a drop down where we can select the different cameras you have as an option. And since I haven't installed the software with any external cameras, these are my three options. But if you would install it with an external camera provider, they will also show up here in the drop down. But we will use a Prediktera simulated camera, which will basically take an already existing data cube and just simulate it as a hyperspectral camera. So we connect to the camera, but before we can record, I just want to go through the different options you have here. So if you have a real camera, you have a focus view that helps you with the focusing of the camera. You have integration time, which help you get the right integration, so not oversaturate the image. Test scan, so you can see that the length you have set and all the different settings are correct, so your image is as good as they can be. Reference, to help you with the references. And we also have the sample mover. So if you have an external camera provider, you need a sample or a tray. And here is the different options that we have. But since I'm using a simulated camera, I don't need it. So we will use no sample mover. When you have gone through all of this and are satisfied with your test images, we close it down and can start our recording. So we can see here the measurement length and also the name. So we will change the name to SB_001_002 for strawberries 1 and 2. And then we press record. So we will record our image, and while we're doing that, we can change the preview that we see to the square root of the RGB or saturation. We can also open the legend to see the saturation level here. When your image is done, we can scroll back up, and actually if we press saturation again, we can see the saturation through the whole image. And we can see that we have some white areas which is oversaturated, but that's fine in this case. What we also can do is to look at the pixel spectra. So if we click explore here, we can look at the spectrum itself to see the spectra. And we can change it from reflectance to absorptions or whatever you want to use. And when you're done, you have the options to either continue with a new image by pressing new here to the left. If you're not satisfied with the image, that it's too much saturated pixels or that you're not satisfied with the spectra that you get, you can remove and redo the image. And when you're finished, you press done. We get relocated back here to the home screen of the software. And we can now see that our previously empty project now has a preview image here of some strawberries, meaning that at least one image consists within this project. So if we press Analyzer, we get into this project, and we can now see here that we have a lot more images, and this is because this is a previously recorded study which we will use to analyze the Brix value of the strawberries, and the Brix value is basically an indicator of how much sugar we have in the strawberries. But before we start doing any analyzing, let's talk a bit about the file structure. So if I press strawberries here, which is the overall project, what I can see within my table here will be images from all of the groups contained within this project. If I press day 1, I will only see images contained from that group, and the same goes for day 2. And if I double click on day 1, I will get into the measurement level. And here we can look at individual images, and what I also can do here is press Pixel Explore, and then we get a very familiar view from what we saw in the recorder, where I can highlight and see the average spectra of those pixels highlighted to compare. I can also change from the pseudo RGB image to single band image to look at a single band. And what I can do here as well is change the band that we look at to see the intensity levels for that specific band. If I add a PCA, an even new window will pop up called Max Variance Image. And now we'll look at component 1, and I can shift it to component 2 as well, but we will keep it at component 1 now. We also get the variance scatter plot, where each circle is 1 pixel. So if I highlight my strawberries here, we can see where we have the pixels for our strawberries. So let's highlight that area, something like this, and press Include Only. We can see we got some stems as well. So let's highlight the stems. They are located over here. So let's remove these pixels. Press Exclude. I missed 2, so let's remove those as well. And we get our max variance image. And we can see that we have some difference within the data here. Now, when we have looked into the data, we can also start doing some analysis. And the first step would be to go back to table and go one step back up so we get into the groups. So now when we're back here at the table, the first thing I will do is just shift my camera so I'm not in the way, and then we will go into Analyze Tree. And here in the Analyze Tree is basically where we build everything for our analyzing. And the first thing we need to do is of course segment the strawberries from the background. So if I press measurement here, which is my images and the plus sign, and go to segmentations, we can see all of the different segmentation tools provided in Breeze. A new one for this release is Segment Anything, which is machine vision based and look at objects, but we will use a PCA model. But first, before we can add that, we need to create that model. So here, towards the left, I have model, which will open a new window where we can add models. And if I press the plus sign here at add, we can see the different models that we have. We have sample, which is our PCA model for removing the background. Quantification, where we have PLS and machine learning. Classification, where we have PLSDA, SIMCA and machine learning. And we can also import, and that's the tool we will use now, because a colleague of mine has already created a PCA model to remove the background for this study. So we press OK. We locate where we have that folder. I have it on my favorite folder, and I have my strawberry PCA segmentation, and I press next here in the lower right corner. And finish. It will now appear here, and I can close this down. Press this plus sign, again, segmentation, add a model, and we have our PCA segmentation. I will increase the minimum area to at least 2000 connected pixels for it to segment that object. And if we go back to table and make sure that we're at strawberry, so we get for all of our data, and press apply changes, it will now do this segmentation for all of our 50 images, and we will soon see the result. So here we can now see the segments of our strawberries, and as we move down in the table, we can see the different strawberries from different images. So what we want to do now, before we can do the bricks PLS model, we need to use these segments and give them a property, as we call it, or basically give them a value that we can correlate as Y data to our models. And that can be done in different ways, but we will import that information from a CSV file. So I go to import, and here we have different import options, and I want to import a variable or ID data. So I press this one. I once again relocate where I have my CSV, and I have strawberry bricks here. I will move myself a bit. So press next. And here we can see, so we will use the segmentation level. We will use measurement ID as the thing correlating the CSV to our table in the software. And we have bricks, and we will use it as a property. And we press finish here, and now a new column has appeared here with the bricks value for all of our strawberries. And what we can do now is that we can press explore here, where a PCA will be created. And each of these circles now is not a pixel like in Pixel Explorer. They are objects, as we can see here. So if I highlight one, we can see the average spectra, and we can also see which object it is. And I can also select bricks here to see how the data and the bricks values are located. From blue is lower concentration of bricks and red is higher. So now, based on these bricks values, we want to create a quantitative model. We will do a PLS model to be able to predict the bricks within a strawberry. So to do that, we go back to model, and here we can see our PCA model that we imported earlier. And now we press add, quantification, PLS, and we can rename it to bricks. We press OK to get into the model wizard. And the first step here is to select the segmentation level, if we want to do it on the image or our average spectra for our strawberries. And of course we want to use the PCA. We can select if we want full or partial cross-validation, how many groups, which type of cross-validation we want to use, and we can also select the property. And in this case we just have one, the bricks, so we will have that selected and press next. Here we can see in the table our strawberries. We get some information in the left upper corner that we have a total of 100 segments. All of them are included, and they are all included in the training data. And of course, we would like to have some images for testing. So we will open this menu here, press by random, select 20%. It will select some images randomly. And now we can put them into a test group. So now they have changed from type train to type test. And we can see that in the information up here as well. We have now 80 train and 20 test. So now we press next, where we get to select which wavelengths and which pretreatment to use. And by default it will select SMV, and we will use these default values and just press next. And now here we will select how many components of our PLS model we want to have. And we can see our data points here, and once again, if I open this menu here and select one of these circles, we can see which strawberry that is. And here we can see we have green donuts and red circles, and the red circles is indicated here as the train data, and the green donuts are the test data. But now we can see our model has two components, and we only describe our R square is 54.5. So we want to add some more components. And we will continue to add components. We can see that the third and the fourth actually start to give us more, describe more. And so for the fifth, sixth, and seventh, we can see that we start to level out. And this is an indication that we will overtrain. So we will go back down to 5 components and leave the model here. In the next step, we can see our model and how well it performs in our data. We can also see some different statistics we get here, like the R square, the Q square, the cross-validation, the R square for the test data, and so forth. And if we are satisfied here, we press finish, and we have now done a PLS model within the software. We close down, and now of course we want to use this, so we go to the analyze tree. On our strawberry segmentation, we press add the plus sign. It's not the segmentation this time, but the descriptor. We can see all the different descriptors that we have here, but the one we want to use now is quantification of properties. So I press that one to get quantification of properties, and it will by default select one of the one model that we have within our project, and we have only one that fits the bricks PLS. We can show the pixel prediction. We can also, if we want to, add some smoothing of the pixels, but we will leave that as none. But what we will do is check this box to show a column which image contains for the train group and which contains for the test. So we go back to table now, make sure we're on strawberries, so we get all the data from group 1 and 2. We press apply changes. It will now predict the bricks value in each pixel in all of our objects, and also on the average spectra. So in this table now, if I scroll down, we can see now here the bricks value. And it's between 0 and 100. So I right click here on the legend, set max, change that to maybe 20, press OK. And we can now see we have a shift in the data and in the visualization. If I scroll down, we can continue seeing the data as it is, and we can both see here in the table the pixel prediction. We can also see the average spectra prediction, and we have the column here containing if it's a train or a test object. So in case here, this one was used as a test object, while the one above was used as a train object. So what we can do now, let's say, based on this value of bricks that we now have, we want to do a threshold and say above a certain value is a good strawberry and below is a bad strawberry. Well, then we go back into analyze tree, and for this bricks model we press the plus sign, and we will do some data slicing. And here we will select the classification descriptor bricks, which is our PLS model, and we will add categories. So first we will change this color to red and call this good, and maybe have that around 7.5 to 20 is considered a good strawberry. And if I add a new one and press bad, it should be between 0 and 7.5. So just to recap, what we have done now is we will classify the average spectra for the strawberries. If it's have a good value based on the bricks calculation, it will be red, and if it's a bad between these values, 0 and 7.5 bricks, then it will be considered a bad strawberry. So we go back to the table, press apply changes, let it recalculate the data slicing. And now, if we scroll, we have a new column here indicating if the average spectra is a good strawberry or a bad strawberry. So now when we have done our analysis of our data, we would probably like to share it with some colleagues, for example. And then we can go to import and export, and we can do it in two different ways. We can do it in a CSV file, where you get everything that we have in the table. You can get that out in the CSV together, if you want to, with the average spectrum for that object as well. You can also export it as an HTML report, and this is a bit more limited. Here you won't get the average spectra, but you get a shareable HTML report looking like this, where you can look at the different images to see the strawberries used. You get to see which group, which sample, and both the bricks value that we use for training and the data and what we predicted with our model. We can also see if it's a good or a bad based on the data slicing in this case. But let's say you want to do it in real time. That's also possible. What we would do then is we would move this analysis tree and create a workflow that we want our software to predict the real-time stream coming from your camera. In that case, we press workflow here and we add a new workflow, add new, and for all of you old Breezy users, this was the old play window. Now when we have our workflow, we can look at the analyze tree. It's the same that we have in the analyzer. So we have our image, we do a segmentation, then we calculate the bricks value, and based on that we tell if it's a good or a bad strawberry. And now we press recorder here in the lower right corner, and it looks a bit different. We have segmentation, we can say if we want to store the data, how we want to segment it, and so forth. But in this case, we just press play here, and I will hit this menu, and we can now see the bricks values. I can also change this to show the bricks content instead of data slicing. I can open the legend, and I can also move this a bit further, so we also get to see the table, where we can see both the segment and the average value. And I hope you like this small walkthrough of the new user interface for a bricks quantification case on strawberries.